Hello everybody, welcome to a review in algebra. On this video, we will talk about transformations and graphs. In particular, how do we use transformation of basic graphs to graph a function. So let's review. First, we'll take a look at some basic functions. We have a constant function, identity function, quadratic function, square root function, cubic function, cube root function, absolute value function, and reciprocal function. This is just a review. We will not go over much detail on the particular of those functions. Next, we'll take a look at the transformation. First, we have the vertical translation. What we have is, starting from a function y equals f of x, if we add something to a function, it will cause the graph to go up or down. If it plus a positive number, it will go up. Minus, it will go down. We'll take a look at just one example here. Let's say we have the function y equal to x squared, and then we have x squared plus 2, for example. By adding 2 to it, the graph will go up 2 units. First we see that is x squared, and now the graph will up 2 units from here to there. And if we have subtract, then it go down. Next, we have horizontal translation. Unlike the previous transformation, the plus k here is adding on the outside of the parentheses, does not attach directly to x. This time the minus h is attached directly to x. So it will affect the graph horizontally, meaning it will go left and right. For example, we have y equal to x minus 2 squared. It will go 2 units to the right. Now let's see. Now we graph x minus 2 squared. Originally we have x squared, and then the graph will go 2 units to the right. And it will be similar. If we add, it will go to the left. Alright, so so far we add a number on the outside of a parentheses, or we add to a basic function, up or down. If we add a number directly to the x inside the parentheses, it will go left and right. On this pattern will repeat throughout the transformation. I put in color code. In blue, if we put the minus just on outside the basic function, it will be a reflection about the x-axis. And if we put the minus attached to x, it will affect the graph horizontally. In particular, it will reflect horizontally. Let's see how it works. Now we have x squared as the basic function. Now we have negative x squared, and we expect this to, the graph will flip vertically about the x-axis as expected. Again, if it is outside a basic function, we're going to the effect will be on the y values, or the graph will change vertically. If it is inside, it will affect the x values. The graph will change horizontally. Same thing for the stretching and shrinking. If we have a number in front of the function, and assume that is positive, because if it is negative, there will be a reflection. If it is positive, if we multiply a number that is bigger than 1, that we stretch, smaller than 1, that we shrink. Stretching or shrinking is not really important. Once we do the transformation, it will come intuitively. But if the numbers are outside of basic function, like this, we will multiply the y values. And if it is inside attached to the x, it will divide the x values by that number, and the stretching and shrinking will work in reverse. We'll see those examples later. But to recap, anything on the outside of the basic function will affect the graph vertically. Anything inside will affect the graph horizontally. And finally, when we put all of those transformations together, we have this order of information transformation. Just like order of operation, we do inside and then outside, multiply, divide, and then add or subtract. We will do inside this first, the function that should be inside of the function. We'll do multiply first and then subtract, even though when it look like we do the subtract first, but always multiply and divide and then add or subtract. Likewise, multiply or divide and then add or subtract on the outside. So that will be the order of transformation: inside and then outside, multiply, divide, and then add or subtract. And then we have this summary. Now we go to some example, and it will make more sense. I put the order of transformation on the top of the screen. Now we have some example. We'll do this example by hand first, and then after that we use the calculator to confirm. Alright, so here we will graph the function h of x minus x plus 4 square plus 3. Just look at the function. Originally the basic function is x squared. Now we have just the plus 4, the plus 3, and the minus. Notice that the minus here is outside of the square, so this will be a reflection. It is outside, so it will be vertically. Or vertical reflection, I should say. And then we have the 4 that is inside. It is plus 4, so it will affect the graph left or right. Plus 4 will be 4 units to the left. And then we have plus 3 on the outside of the square. It will affect the graph vertically, and plus 3, so it will go up 3 units. Now put all of this together. The order of transformation will be as follows. First, inside and then outside, multiply, divide, and then add or subtract. So the first thing we'll do is 4 units to the left. And then after that, multiply, divide. This is multiplied by a negative 1, so 2 will be vertical. Reflection, and then finally will be 3 units up. So first, the basic function is the x square. We will not plot the perfect graph, we just get the idea of the transformation. So x square look like that. Just get the idea of x square. Next will be 4 units to the left. So every point will go up, go to the left 4 units. And so it will be like this. So just move 4 units to the left. And then vertical reflection, we're going to flip this upside down. And then finally, we move this 3 units up. From that point up, and every point move up 3 units. So it should be like this. So it will be like that. Now let's confirm with the calculator. Right, we have x squared. Now we're going to graph minus x plus 4 square right, x plus 4 square plus 3. And then let's look at the graph. And as you see, 4 units to the left reflect, and then 3 units up, and that's what we have. Now let's look at another example. This time we have square root of x. The basic graph square root of x look like this. Right, let's just look at what do we have. First of all, the plus 4 here outside of the square root, this will affect the graph vertically, in particular 4 units up. And then inside the square root, this will affect the graph horizontally. We have the minus sign and the minus 2. The minus sign here will be horizontal. Reflection. And then the minus 2 here also inside the square root, so it will affect the graph horizontally, in particular minus, so it will go 2 units to the right. Now, so that's all the information we have. Those are all the information we have. Now try to put them together. Always inside and outside. So those two first. This will be the last transformation. Of these two, we multiply with the negative sign first, and then we subtract later. So the first thing we do is horizontal reflection. And then we go 2 units to the right, and then 4 units up. Right. So first, horizontal reflection. So we will flip the other side, and then 2 units to the right. So that point 2 units to the right, and all the points 2 units to the right. So it will be like that. and then 4 unit up. Just move everything up 4 unit. 1, 2, 3, 4, and it will be like that. It's just a sketch. The transformation is more important than to try to get all the points accurately. Right. And now let's confirm that with the calculator. We have the square root of x as the basic function, and then we have the function square root of negative. Notice if you use the negative, it is this negative sign and not a subtract. So we have negative x minus 2, get out the square root, and then plus 4. And then we will graph. So first we have the square root function, and then we do have this, the transformation of the function square root of negative x minus 2 plus 4. We will do one more example. This time we have the absolute values. Absolute values function is a v. So the basic function is like that. Now let's look at the transformation. Then what do we have? First, outside of the absolute values, we have the 2, and then we have a plus 3. A 2 here, of course, what we do is we will multiply the y values by 2. So I just write multiply y values. It is on the outside, so we multiply to the y values. If it is inside, we divide by the x values, by that number. So multiply y values by 2. Now, if we multiply a number, let's say if the number is positive and we multiply by 2, that number will get bigger. And if it gets bigger, meaning that we stretch. Stretch to get it bigger. And this one on the outside will affect the graph vertically, so it will be stretched vertically. Or by a factor of 2. So that will be the first one, the first transformation. We're not doing that first, but one of the transformation. The plus 3 here, outside the square root, outside the absolute values, so it will affect the graph vertically, and this particular will be 3 units up. Now inside the absolute values, we only have minus 2, meaning 2 units right. So those are the transformation we have. And then the order of transformation again will be inside and then outside, multiply, divide, and then add or subtract. So inside first, we only have the minus 2. So the first thing we do is move this 2 unit to the right. Next, we have the multiply by 2 and then plus 3. Always multiply first and then add or subtract. So we instead of writing everything like this, we just say we'll have the vertical stretch by 2, and then finally we have 3 units up. At first 2 units to the right, so move everything 2 units to the right, 1 2, and then we still have a V, but 2 units to the right. Next, stretch, vertical stretch by 2, meaning whatever the Y values is, we're going to multiply by 2. So this is the Y values, the vertical distance. We're going to make it twice as long. And whatever the Y values is, we're going to double that distance. So it's about 4, so like that. And then we have this graph. And then whatever the Y values is, we're going to double the Y values. So we say we stretch the graph vertically in that direction. And then we just move this up 3 units. This point go up 3 units. So we have this graph. Right. And we'll confirm with the calculator. First we need absolute value. It will be under math. Go to the second tab, numerical. The first option is absolute values of x. And then we have 2 absolute values of x minus 2 plus 3, and then we'll graph that original absolute values. Now it stretch a little, move to the right and then up. Alright, so that's all of the sample for this review. I hope you find this video helpful. Thanks for watching.